Yeah. Today I'm going to cover a great deal of territory based on actually years of research since Drupa 2004, but the first UV printer I saw was in the year 2000. Actually, UV printers began in the 1990s. And in the last 6 months, I've spent most of my time visiting UV printer factories. I've been to Israel 3 times. I'm going to Korea for my 3rd time in a couple of weeks. I've been to UV printer factories in China, Switzerland, literally all over the world. I've been to the ViewTech factory 3 times. I've been to the TechWin factory in China, very impressive factory there. So there's a lot of information compressed into these lectures. So at times, I may go through the slides relatively quickly. But we will go through more quickly if the button will work. The first lecture is describing the difference between solvent printers and UV printers. Solvent printers use a very delicious carcinogenic cancer-causing ink that not only causes cancer to the people in the print shop, but also pollutes our environment. UV ink is labeled as more friendly. There are no VOCs, but I think the difference between UV ink and solvent ink is we know what kills you in solvent ink. We just don't know yet what the different ingredients in UV ink will do to you. So it's not exactly something you should eat or sniff or anything like that. All inks are bad for your health, except edible inks. There are inks you can print on birthday cakes and cookies. Most UV printers that existed in the early years were actually based on experimental solvent printers. So UV technology, which means taking a light which is literally almost as hot as the surface of the sun inside that UV lamp, you use this UV light to trigger chemicals in the ink so those chemicals are solid, so the ink is solid instantly. That's what those lights are for. Solvent printers, and here we have the Kyundo solvent printer. That ink can't dry except on 1 or 2 materials. So if you print solvent ink on wood or on stone or on ceramics, the solvents in that ink, the liquid part of the ink, the carrier in the ink that makes that ink flow through the printer out of the jets onto the material, that liquid has nowhere to go other than into your nose and in the atmosphere and everywhere else. So you need to get rid of the liquid carrier of your pigments. All you want to do, the whole purpose of an inkjet printer is to get color onto your material. But to carry that color through the printing system and out those nozzles, millions and millions of drops, it has to be in kind of a liquid form. With the UV printer, those lamps immediately flash dry the ink so it can print on almost any material. But because this is very complicated, printer manufacturers have had to experiment. And they've always experimented with the movement of the material through the printer. And as we see here, the Kyundo, several years ago, they are all trying solvent flatbed printers. Because with a UV printer, what you're trying to do is print on rigid materials. Normally you print on a flexible material and you mount it in a separate operation. Somebody, a human being that you're paying a salary to, picks that material up, walks somewhere, puts it on foam core, and has to kind of mount it to that foam core. That's expensive. The idea is to print directly on the foam core and forget about printing on the material and moving it all around. So Infinity is another example. They started out with a solvent-based flatbed. This is so they could learn how to feed that material through the printer so it doesn't skip and stutter as it goes through the printer. Because every material has a different coefficient. Some are slippery, some are rough, some have texture on them. So this is why in the beginning, by beginning I mean the 1990s, 2000, 2001, pretty much up to 2005, everybody was using a solvent printer just as a guinea pig to to figure out how to move those materials through the printer so that the printer would not leave banding tracks. Some companies gave up totally. Western Graphtech is I believe it's a Taiwan company in that part of the world. They started out with an eco-solvent flatbed, and they just finally gave up. Several companies have given up totally. And I think as emphasis for how difficult it is to make UV printers, this year, 3 companies went out of business. DuPont, one of the wealthiest chemical companies in the world, the company didn't go out of business, but their UV inkjet printer division went out of business. They made the mistake of selecting a factory in China that did not produce a very reliable printer, and that was the Flora printer. So DuPont is out. Lusher is a Swiss company. They made the mistake of making a UV printer that was too big. It was simply too big to function, cost $500,000. They sold about 20 or 30. They did not function. And then Zund made the mistake of using the wrong kind of ink chemistry called cationic chemistry. That chemistry failed. It had the problem that, yes, it dried nicely on the print, but it also dried spontaneously up the ink tubes all the way back into the ink reservoir. So that's something you don't want to have your entire printer dry all the way back through the ink tubes. By dry, I mean solidify. So Zund still makes the cutters, but Zund is no longer making printers. This is just to emphasize how complicated it is to make a UV printer. Even McDermott ColorSpan, which is so successful that Hewlett-Packard just bought them, their first flatbed printer was a solvent printer, again, as they are experimenting. There are 3 companies that still have not produced a UV printer. By not produced, I mean they've not shown them to the public. Now, since I'm an inquisitive professor, I always stick my nose in where I'm not supposed to go. So I do know about all those printers. On some of them, I'm under non-disclosure. Non-disclosure means I have signed a piece of paper that says they will allow me to know about their products that they don't show to anybody, but I'm not allowed to tell about them. But the fact is, I know about them, so when I study the world of inkjet printers, I know not only the printers that exist today, I know the printers that are going to come out next month, 3 months from now, 4 months from now. Some cases, the manufacturer doesn't want me to know anything about them, and they very politely tell me that, and I smile at them and I say, you know I'm going to find out anyway, and they smile back and say, yes, but we're not allowed to tell you. I pick up the telephone, and it may take 45 minutes, it may take 45 days, but sooner or later I find out all the details of their printer. So Roland is an example. They're not showing a UV printer because it doesn't work. That's how I found out, by picking up the phone for 45 days and email and having my antenna up at trade shows and receiving signals from all over the world. Roland, though, showed a prototype of their UV printer as a solvent flatbed, but they showed it at a very small trade show that they assumed I would not know about and would not be there. Unfortunately for Roland, I was there, and I now have all these photographs of the Roland prototype. It's a very small printer, and probably, if they had produced it as a UV printer, would have been commercially unsuccessful. It's simply not big enough. By the way, Roland makes very good printers, but for reasons that I don't fully understand, their success in UV has been most politely described as stalled. They'll get it right sooner or later, but right now, the UV printer that they're trying to produce, this is their solvent version, but one of their early UV printers that they're not showing anybody is very similar to this. Again, it's just too small. In most cases, every manufacturer that has started making a flatbed using solvent ink, the minute they've understood how to make UV chemistry flow through that printer, they have stopped their solvent flatbed. What that tells us is that solvent flatbeds don't work, in the sense that solvent ink cannot cure or dry out on most flat materials. The Chinese, though, are still trying to experiment with flatbed printers using inks other than